So, folks, this is Alessandro Voza from Microsoft. He's going to talk to us. He's a principal software engineer at Microsoft. He's going to talk to us today about managing multiple clusters with GitOps and ClusterAPI.
Are we live already?
Yes.
Of course we are live, and I'm a fool. Thanks, Chris, for organizing this. Thanks the GitOps working group. Sorry I'm late. I thought I was still in the other session, so let's see how it goes, right? So this is a live session, right? So
yes.
It's I didn't record anything. I did record some screencasts, so let's see how it goes. It's gonna be fun. And yes, I shared the link to the slides, both OneDrive and Google Drive on Slack. So
cool.
Bear with me. It's going to be very hands-on. I mean, not much theory of GitOps or ClusterAPI, but I'll show you what to do with these two things together, right? So can you still see my screen?
Yes.
Yeah. Okay. Great. So we're going to talk about a little project of mine and other people at Microsoft, and of course, like in the CNCF community, uniting GitOps and ClusterAPI. This has been mentioned before today. ClusterAPI is a great project using a lot of places to tame the complexity of multiple clusters, right? Or to manage clusters through native Kubernetes object primitives, right? So shortly, I don't know if it's going to take the whole half an hour, but we'll definitely try to stick to the time. So
however long you need.
Yeah, fine, thanks. ClusterAPI, what are ClusterAPI, how to combine GitOps and ClusterAPI. Little demo that's recorded, so that's better. And so wrap up in QA. I'm a CNCF ambassador. I have the just arrived hoodie. So I've been capped for more than 2 years. An ambassador is awesome because I get to serve my community in Amsterdam and across the globe. And it's been a wild ride. It's lots of fun. I met amazing people, absolutely the best people ever. And this is one of the best community ever. So if you ask me what is the biggest achievement I ever did, well, this is it. 2019, we organized the first and so far the only Kubernetes community days in Amsterdam. And on stage there's the amazing Andrew Randall, now at King Volk and soon to be at Microsoft. We had a great first edition. Of course, we had to skip 2020. We skipped 2021. We're going to come back in 2020 with vengeance and a bigger than ever and safer than ever, of course, edition. So stay tuned. Community.cncf.io is where you're going to see this event and all the other Kubernetes community days around the world popping up in the coming months. The ClusterAPI. So I don't pretend I will give you a great intro on ClusterAPI because there's so much out there. Every KubeCon there's 2 or 3 or more talks about it. There's an entire SIG dedicated to it. So I love the project. It's extremely cool. Got a very nice logo right there. Which means basically Kubernetes all the way down, right? So it's Kubernetes on top of Kubernetes on top of Kubernetes, because that's what we do as a community. We just love so much, and the paradigm of Kubernetes are so universal, right? So API first and the controller loop, they're just so universal and so useful that naturally was a natural extension of the project to also manage the cluster where Kubernetes runs in a declarative way, right? So the goal of the project is to adopt this great paradigm, so all the Kubernetes ideas for the creation, configuration, and management of clusters. So released in 2019, now just released a few months ago the Alpha 4. So This is highly experimental. This is not something you can possibly think of using in production yourself, although some of the providers are so mature that that big companies are using them for serious stuff, right? So the whole project is on GitHub, of course. It's part of the Kubernetes project. It's sponsored by an SIG, a special interest group. And the core of it is really the ClusterCTL API. So we'll see how it works, and I have a example repo out there, and then I'll show you in the demo. So if you want to know more, I encourage you to follow the session from Marcel and Jason on Friday. It's a great session, and for sure you're gonna get everything that you need. It's a deep dive in it, and these people are contributors, and they know way more than me. And last time at KubeCon Europe 2020, Cecile from Microsoft and Nadir from VMware also had a deep dive, and I learned a lot watching that talk. And please go there. There's a link in the presentation. So what is the Cluster API, right? So what is at the core is a way to manage clusters in a declarative way, native objects, native Kubernetes objects. So there's an object describing the managed control plane, an object describing all the machine pool, all the machines that form a cluster, and so on and so forth. At the very core is a bunch of controller managers, right? So running on a management cluster that can be anything. I use AKS because it's the easiest thing for me, being a Microsoft engineer, but you should be free to use any compliant Kubernetes cluster out there, which is at least 114 or something like that, to use as a management cluster, to host the objects that will form the core of the workload cluster you want to deploy, right? So the only requirement here is really that this management cluster can talk, for example, to the VMware vSphere API or Azure API. So make sure that the cluster you're using as management cluster can actually perform those actions. So if you're using a cluster that is firewalled, of course, and you cannot talk to the public API with Azure, there's no way you can create a cluster in Azure. And similarly, you have to make sure that you have the right credential to create clusters. And in the demo repo, you will see there's a way to use it with Azure. There are many providers out there. Providers are extension to the core of Cluster API. What really makes this thing interesting, which is it's sort of like a CRI. It's an interface between the Cluster API core and the cloud provider, or the bare metal provider, or anything really that can spin up a Kubernetes cluster, right? So could be on-premise, and there is, I think I saw a SSH provider for already deployed machines, so machines that you don't need to deploy from scratch. Packet is a great provider, and to provision bare metal through their own API, and then install a Kubernetes cluster on top. And of course, all the major cloud providers have one, and I'm particularly interested in the Azure provider. So just a bit about nomenclature. When we say CAPI, we intend the core, so the Cluster API core. And for example, when I mention CAPZ, is where I'm referring to the Cluster API provider for Azure, which is the implementation of the Cluster API for talking to Azure and provisioning clusters on Azure. So again, taken from the official the Cluster API book. I think there's a link somewhere, but it's where most of the information about Cluster API are stored. It's a documentation website about Cluster API. So the Cluster API is comprised of several objects. Of course, all these objects are CRDs, are customer resource definition, and all of them have, of course, a controller associated with it. So, for example, there is a cluster controller that checks the status or the state of the cluster objects and make sure reconciles them with the desired state, and so on and so forth. There are infrastructure providers, there are machine pool and machine set. I'm not going to go in detail about what each of them does because I wanted to keep it short and very hands-on. I might not even understand everything what I'm saying, but again, I refer you to the people in the know, the contributors and the people that really understand, really can shed more light on it. So at the core is this, right? So you start with a management cluster, and the management cluster will create workload clusters in the infrastructure provider of your choice. That's the core of it. What really triggers me for this talk and the blog post I published in December is that the ClusterAPI for Azure community introduced the AKS provider. So the Azure Kubernetes service is a managed service in Kubernetes. Historically, the ClusterAPI is being used to deploy unmanaged clusters where you have to manage both the control plane and the workload nodes. This is what historically ClusterAPI, or at least the way I saw it for a long time, I thought it was a thing to deploy kubeadm, basically, base clusters with one or more nodes in the control plane and one or more nodes as VM scale set, for example, in Azure, or whatever that's called in AWS. But for me, it was mainly a thing for a managed cluster, which are great, of course, and people need them still. But for me, and I think for a lot of people in the industry, manage is the name of the game for Kubernetes, right? So the thing that really triggered me is that the ClusterAPI for Azure released the AKS driver, or the infrastructure provider for the managed service of Kubernetes. So that kind of made me think maybe I can put this thing to use, because I saw it for me, for myself, and for my customer. I'm still spinning dozens of clusters a day, or more than that in a given week. So I need to manage complexity. I would like to have a way that I can create clusters in a programmatical way instead of the classic Azure CLI commands, right? So that's a imperative way of creating clusters. Instead, I wanted a way to describe all the clusters that I needed in a declarative form, possibly in Git, hence the GitOps in the title, and then let the system do its magic and create the infrastructure that I need when I need it and with the characteristics that I wanted. So I got to think, and I thought there was a great place to start. So this is what the ClusterAPI provider for Azure, and specifically the Azure the AKS infrastructure provider does. So there's an object called cluster. That's the root of all the objects. So you start with a cluster object. The cluster object creates, or as children that refers to the cluster object, two kind of children. So one is the Azure Managed Cluster, which represents the AKS cluster, and the Azure Managed Control Plane, which represent all the properties associated with the AKS itself, right? With the control plane. As you know, there's a distinction between, even in AKS, there's a control plane properties. For example, if the cluster supports Calico, or if the cluster uses Kubernetes or Azure CNI as a network provider. Those are properties that are valid for the whole cluster, or managed identity, for example, for that matter. And then there are node pools, and the node pools have their own set of properties, right? So, and then naturally, those pools are represented by their own object. In fact, so when you create a cluster, there's a Azure Managed Control Plane and Azure Managed Cluster. You need to create those objects as well, referring to the cluster object. This will actually create infrastructure, will inform the ClusterAPI provider for Azure to actually go to the Azure API and create a managed cluster for you. There's always a system pool, so you need to use the default pool ref, and all of this stuff is in the repo, of course. So there's those meshing pool are actually abstraction over the actual VM scale set for that are attached to your AKS cluster. So there's always a machine pool 0 or the default that is referenced by the Azure Managed Control Plane, because the control plane needs to have a default system pool. But then you can create also multiple node pools. You can create what you need to run your workload. And then, of course, all of these, they trigger actual infrastructure, right? So all these abstraction objects in your management cluster, all these objects are actually triggering the controller manager to actually go and create infrastructure for in Azure. I'll quickly glance to this. You're gonna interrupt me, I guess, if something goes wrong. Yeah. So, and we are back at this. So, and then I thought, okay, that's great. Let's see if I can put all these objects into a Git repository and let my management cluster create stuff for me, right? So this is actually the best thing ever. I'm managing my cluster fleet, my cluster estate as a GitHub repository, right? So, and then with the power of ArgoCD, you can do this with Flux, and I have colleagues. There's a link at the end of my talk where somebody from Microsoft also explored the same thing, but with Flux. Great tool. They're all kind of the same, and I hope the GitOps working group will eventually come with a single with a better unification of Argo and Flux. But for now, Argo is what I like. Also because everybody knows Argo is a great GUI and graphical interface, and I like to see my clusters in a graphical interface, since Flux doesn't have one that is at that level yet. So I have a GitHub repository. Is the same where you can follow along this talk. And I have a folder called clusters, and everything I drop in there becomes a cluster in Azure. So it could be something else. It could be if in my case I only deploy the infrastructure provider Azure for AKS, but nothing stops you to deploy multiple infrastructure providers and drop cluster definition in there that deploys different things, right? So in my case, I use an Helm chart because there are multiple objects you see that needs to be created at the same time to get a working AKS managed cluster. But I'll be happy to collaborate. I'll be happy to see different example of this Helm chart where you can use for example deploying on vSphere or Google Cloud or on-premise infrastructure. And this is where things are really interesting. So the management cluster, of course, being the one that creates this infrastructure, also stores the kubeconfig for the management cluster, for the workload clusters. So since ArgoCD is running in the same cluster, it's just a few commands away to add the workload cluster, the remote clusters, as clusters in ArgoCD, and then let ArgoCD manage those clusters as well, also in a GitOps way. I was thinking about this. I mean, I just have a couple of commands that do that, but it would be interesting to see if so ArgoCD. I explored this. The only thing that I don't like about our ArgoCD managed clusters, they are not declarative. So you have to go through the command line. There is no object in ArgoCD that describes a cluster. So for now, I have to revert to just simple commands, but it's all in there, right? So I retrieve the kubeconfig, I give it to ArgoCD, and then ArgoCD can pick up another folder or another place where the workloads, so the definition of application that should be deployed on those workload clusters are defined. In my case, it's the same repository, just in a different directory, and I can assign applications to each cluster. And then, so ArgoCD now can distribute this application to different clusters. There's unfortunately still, there's still room for improvements. There's still not, I haven't found a way to actually have one definition that can be deployed to multiple clusters, because the cluster is a key in the app that can be that is unique, but maybe in the future, maybe with application sets, and I'm going to talk about application sets right now. So this is all nice, and I thought great, but I don't want to define one application per cluster. So I discovered a thing. It's still like a new feature of Argo called application set, right? So I thought, oh, that's interesting. I can use this. So there's an interesting feature of that called Git generator. So I keep my cluster definition in Git, but I create an application set. I call cluster application set, or a workloads application set. So what the application set does is that points to a folder in GitHub, and everything that is in there creates an app out of it. So it's kind of it goes through a Git repository and creates as many apps or clusters, because clusters are apps, as needed. So, and then all these things can be applied. So in a different way to show this is that, so I have two application sets, a cluster application set and a workloads application set. Of course, those are managed by a controller. That you need to install extra, so it doesn't come with the standard manifest of Argo. You have to install it separately, but it's in the script that is in my repo. And then one cluster application set looks at clusters folder and creates the clusters, and then there's another workloads application set that looks at the other folder, and then in this folder, in the workloads folder, you match the application to the cluster, right? So ingress with this characteristic goes to cluster 1, and I don't know, cert manager with this Elm values goes to cluster 2, and so on and so forth. So you really, now you have a full management solution for multiple clusters, multiple applications that can go on those clusters, and I think is kind of beautiful, although it's still rough around the edges, of course, and all using pre-alpha stuff. But I think I found a good way to manage multiple clusters on multiple providers. So now let's see how you can see, if you see them all right. So this is the first demo. I was hoping it would go full screen, but that's fine, I guess. So I just ran the commands. It's a shell script with just two parameters: the location and the URL that I want to use to look at Argo. So I cut this thing, right? I cut several minutes of this. I trimmed the video, so this takes 2-3 minutes to provision a cluster. That's my seed cluster, my management cluster, right? So the cluster is deployed, then the script goes on, installs ArgoCD. ArgoCD takes some time. So I also put some kubectl wait commands in there, because I want the script to finish by itself. And of course, like things like cert manager, they need to complete and be up before you actually can create the actual cluster issue, for example, right? So it deploys ingress, it deploys a bunch of stuff, and of course, like deploys the ArgoCD and the ArgoCD application set controller. And then the second script is to deploy the cluster API. So the cluster API controller. It's a CAPS setup. So fetches provider from GitHub, and then eventually provision the cluster API core, the CAPI in the CAPI system namespace, and then the cluster API provided for Azure in the CAPZ system namespace. And if you look at it, I think I did well, and then also the third script is to install the root app, the app that triggers everything and will point to the to my GitHub repo. You can fork it and use the script to just change the name, change the to your fork, so you can play around with your own stuff. So, and then eventually I get SSL terminated ArgoCD interface. And now what I'm doing, I'm moving from disabled, I'm moving a folder with my AKS cluster definition in there. I move it, I commit to Git. I add my, so now the cluster folder contains a definition for a cluster, right? And that's definition. You see there's a, you can follow along on GitHub. I can also show you quickly. But what matters is that now Git ArgoCD will eventually pick up the changes on GitHub and will create an app that will create in turn the Elm release to deploy the AKS3 cluster. So why is this? Because I use an application set. Remember, so application sets, they create an app for every item in a specific folder on GitHub. So the Git generator. And eventually, you can do watch kubectl, get cluster API, and you will see that, yes, so there is a cluster in provisioning state. This cluster in provisioning state just started and is not yet an actual infrastructure. There it is. So after a couple of minutes, you actually see there is a cluster being created in Azure. And this is, I cut some time in it, but that's exactly what you see at after 11 minutes, that you have two node pools. One is the system, one is the workload pool. So one cluster with actually the infrastructure in Azure succeeded, right? So created. Now there is another. Let's go to the workloads. So now I have a cluster. What should I do with it? Let me add a workload to my Git repository. It's just in the disabled folder, so I just move it into the right place. I'll just move it to the right place, and then eventually ArgoCD will pick up the changes and the workloads. Go on. So first I need to so these are the commands I was talking about. So you need to log into Argo, ArgoCD login. Then once you have the ArgoCD login, once you have the context, you can get the kubeconfig as a secret from Kubernetes itself, and then feed it to Argo. And now Argo has the knowledge of this remote cluster, this AKS3 cluster, where you can just deploy application. Now I can get this workload and move into workloads. And again, I cut some parts of this video because it takes some time for Argo to pick up the changes in GitHub, and takes even more time for clusters to be created, deployed, upgraded. So bear with me, but trust me, it all works. And lo and behold, eventually, so see, nothing really changed yet, but if you skip a few minutes forward in time, I think GitOps is not for the impatient, right? So you have to trust the system that eventually will reconcile and eventually will affect your actual infrastructure or your actual cluster, but it's not something that I don't think it lends itself easily to demoing, because you really have to just let it go and be patient, which is not exactly one of my forte, but well, if you skip a bit, you will see that eventually these workloads, should have cut this one, yes, eventually you will see that the root app picks up, there's the workload application set will pick up the ingress, and now the remote cluster, and I think I'll show you here as with kubectl, I will actually get secret again, or get, yeah. Yeah, so that's exactly what happens. So now I'm looking at the AKS3 cluster, right? So the remote cluster, and eventually you will see that when this gets synchronized, then on the left you will see that some pods will be created. Yeah, that's exactly ingress, AKS3 ingress, blah, 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 and then eventually the ingress controller will be deployed. So this is using one ArgoCD to manage application remotely on different clusters, right? So and then you see that there's a thing there. Last thing extra before, I don't know how much time I have, maybe I'm too short, but doesn't matter. So not only you can manage workloads, but you can also manage the infrastructure itself. You can see here I have a AKS1 cluster at 119.7 version with a simple git commit to bump up the version of the cluster to the latest, 120.5. Then again, I push my commit, and then I do something else. I really don't should not monitor this, but this is what happens. Of course, eventually the cluster will get updated by itself. So if you scroll through, you'll see the manifests between the desired state and so the parameters of the cluster is actually so the AKS1 parameter is bumped to 120. Yes, it was still 119.7, but if you leave it a second or you push the sync button, eventually it will get to 120.5. And so without really thinking too much, that's how you do upgrades to an entire fleet of clusters. And eventually you will see that the infrastructure itself, the actual Azure will trigger an update. Yeah, see, Kubernetes version was bumped to 120. The cluster entered the upgrading state, which means that things are moving. You can see that here that in AKS node pools, it scales up. So the node pool is a replica 1, so there's only one node. But during upgrades, AKS, Azure will increase the number of nodes. It will bring up a 120.5 node. And when that node is ready, we'll decommission and destroy the old node. So there's no in-place upgrades for AKS. That's how we do it. I think it's a safer and it's more clean way to do it, because then the new nodes will get all the updates, all the new image version, and there's clean upgrades for Kubernetes. So that's how you do upgrades with a git commit, as GitOps is operation by pull request. Well, of course, this should have been a pull request, you know that, but I collaborate with myself. It would be pretty dumb to approve my own pull request, so I just decide to commit. some links because it's I'm always standing on shoulder of the giants, and thanks to my colleagues also that also explore this for other controllers like Flux. And I am about done. So
Awesome.
Yeah, that's about it.
Cool. So just to let folks know, lightning talks have started. If you want to stick around here for questions, though, that's fine. Alessandro, the #1 question most upvoted is, could we do GitOps with Azure DevOps out of the box? Or should we use other tools like Argo? Yeah.
No, so the two things are, no, you can use Argo with Azure DevOps. I mean, Azure DevOps has a Git server is just another Git server. So as long as you can, your cluster can talk to Azure DevOps, there's no reason why you should not be able to store your configuration in Azure DevOps, which is pretty good because it also it comes with a lot of stuff that is not per se related to GitOps, like boards and bar down charts and all sorts of stuff. So no, it is totally possible. It's just that GitHub is just the go-to place for me to do this stuff.
Got it. All right, the second most upvoted question. I assume this management cluster will become kind of a managed service in Azure. Do you see it as a replacement for Google Anthos multi-cluster management?
I will. Well, I think it is a real possibility that we could use a hosted management cluster, a minimal cluster to do this stuff. There's one thing. Think about that also I needed some time to think about. The management cluster can go away. Literally, you can destroy the management cluster, recreate, reapply exactly the same manifests. The controller will come up, will compare the situation. So we'll talk to Azure and say, do you have a cluster called AKS1 and a cluster called AKS3 there? Do they have this characteristic? Yes. Okay, then my job is done. And so you can replace the management cluster as you like. It's kind of a stateless operator, right? So a stateless object that applies what the real source of truth is Git. So no matter sure, the management cluster now contains objects in etcd and so on and so forth, and kind of a state but the state is only a mirror of what's in Git, because ArgoCD makes sure of that. Right, so that's the reason why. But I would love to not need to spin up a cluster to do this stuff. Yeah.
Mm. Yeah, that's a good point. Next one is, I see you chose the strategy of deploying into the child clusters from the central Argo instance. What are the pros and cons compared with bootstrapping a dedicated Argo inside each child cluster?
I think the advantage for me is that I want to have a single pane of glass, single view of everything, clusters and the apps that runs on them, right? So I don't want to log in 10 different Argos. I think the power is in there, like when you have a central management for a cluster and application and how they connect. Maybe the Argo UI can show me better. This application set, for example, is new, so I don't see the application set, and I think I can. Well, I could actually show you the live thing. Yeah, so if you can see my screen, so the root app has application sets, right? Application set for cluster, application set for workloads, but I don't see these in the overview, and that really, I wish I could see, because these are children of an application set. I think that it's very new, so it would be great to have like an application set container that I can drill down and go into each cluster. But yeah, it's you can do this only when you have a single ArgoCD that manage multiple clusters. It's maybe less secure because of course you have the kubeconfig of all your clusters in there. So that's less than ideal, but hey, it's a good point.
All right, folks, that's all the question time we have. Again, please jump out to the sessions and join us for the lightning talks. Thank you so much, Alessandro, for coming on live and doing this demo and talk for us. Great talk. You know, if you have more questions, Alessandro, will you be in the GitOps channel on Slack? Yeah, please feel free to ask Alessandro there. Tag him, and I'm sure he'll be happy to answer. So thank you all very much, and to the lightning talks.
Woo-hoo. Thank you. Goodbye.
Bye.